Hi, and welcome to a very special Rigonomicon.com update. It's been a while since the last one, and there's been a lot of development since. We have a new version of Rigonomicon 0.40 alpha. It's a brand new recompile of all the plugins. I've been checking stuff, I've been verifying, making sure everything works well. And so today, well, by the time this video is live, you should be able to download the latest version. It's going to be available, and this is a reason why I've, it's taken a while to get it going. And one of the things that I spent the most time with was trying to get Maya installed on a new computer, a new setup. And it was quite painful. It took a very long time, and I even questioned if I should still support Linux, seeing that there's such a small percentage of people that actually use Linux. But there's a few students that did use it, and also there's some big studios like Pixar and DreamWorks that have a lot of Linux-based, or have a lot of their production in Linux. That's something that not a lot of people know. So it's a good idea to just know how it works. And also, if I want to make these tools available to everybody all the time for everything, then that's a good thing overall, even though it was very difficult to do. Right now, Autodesk isn't making it very easy, and they haven't been keeping up to date with all the updates in Linux and the different distros and all the changes, and they even have straight up blocks if you're not using the ones they recommend. So it's not just so much a recommendation, it's like you're basically hacking it to make it work in other distros. I strongly suggest just using the one that they recommend. So I have multiple installations of Linux for different reasons. I might have a video talking about this, and also maybe how things work on Mac. If you're interested, leave me a message in the comments, and just let me know if you're interested in that. I could put together a little video on how to install and get everything to work, so that it works in Linux and on Macs, if you're interested in that. So yeah, Rocky Linux is, I won't go into too much detail. Like I said, I'll do that maybe in another video, but Rocky Linux is a supported distribution of Linux. It's free. It's pretty solid overall. I actually like it quite a bit. The installer setup process is very difficult, even with the supported ones. There's a lot of gotchas, and it can get messy. Although I'm using what I've got here to actually make it work on other distros now. So anyhow, so new version now compiled for everything again. Everything's up to date, because when I was doing the alpha tests, I was making sure that that it worked on Windows, and as we're getting to the end of the alpha stage, I think I'll be making a full release. I need to make sure that it's working on everything else. Okay. Other than that, this video is going to be a very important video also, because this is quintessentially what the Rigonomicon is about. So we're going to be talking about something called ribbons in Maya. I'm going to just launch 2026. Like I was mentioning before, I'm compatible with Maya 2024, 2025, and 2026, Mac, Linux, and Windows. We're going to start a new file. Okay, so what I was saying about the video is that this is a very important video, because it is quintessentially what the Rigonomicon is about. I'm going to take something that is commonplace and commonly referred to as an advanced form of rigging, or an advanced topic in rigging by many people, and I'm going to ask questions, and unfortunately I'm going to have to poke holes at the current method or meta for one thing in particular called Maya ribbons. If you're not too familiar with this, Maya ribbon, we're going to make one really quick here. I'm going to use basically the instructions of many videos that I've seen. They all pretty much do the same thing. That's something that's kind of scary. They all make the same mistakes. They all make the same crappy setup, and I'll explain why. I will back that up with I'll show you why it's crappy and why we need to not use it. or if you are, at least follow some of the things I'm going to mention here that none of those videos that are online ever talk about, because I think they simply do not have the tools to be able to see that what they're doing is not actually all that great. So we're going to go through that now. And then I'm going to show you the Rigonomicon way of doing it, which is basically getting rid of all the stuff that's silly and going straight to a method that is works well. And I'm also going to show you something for splines in general and for how you can approach ribbons by other people who are really trying to figure this out and trying to push forward instead of just doing what everybody else is doing. Okay, so let's get started. I'm going to create a NURBS primitive, and I'm going to go to. I'm going to do this fairly quick. I'm going to make a plane with options, and I'm going to use the option settings that they had in their video. So I'm not going to go over it too much. It's going to make it a certain width, certain length. It's going to be cubic. Cubic's important. That is going to be important because later on we'll talk about how we're going to be replacing this with our own equations. Don't worry, I have buttons that create stuff for you, and it won't be a big deal. It's already included in 040. And it's going to break it up into 8 pieces and a single strip. So we're going to create this. I'm going to zoom in, and I'm going to make sure that we can see it when we can see the divisions even without that. And quite often, most of these videos remove the grid. They all kind of do the same thing. So now that we have this, basically the idea is we're going to set this up so that we can control this. Because it's a NURBS surface, we'll be able to control it so that we can twist it, and the bones that are going to be the ones that go onto the rig later that we're going to use for the skinning are going to be locked onto this surface, and we'll be able to control it, and it's going to be beautiful, right? So okay, so it's going to look great. So the first thing that you're going to go, what the heck, is we're going to select this, and now I'm going to go into, oh, my cat's chiming in. It's okay, come on, buddy. Yeah, you're cranky? Okay. You also don't like using this method. Okay, it's okay. So we're going to go into the nHair, and we're going to go create. So already you should be kind of going, what the heck? We're using hair to do a ribbon. Okay, so that is a good reflex to have, because that's part of the reason why I don't like this. It gets complicated, and it's a silly workaround to a problem that should have been solved directly. Okay, so I'm going to just use the setting options that they do in the video. Basically, they make sure it snaps onto the edges, and the count is going to make it so that you end up with 1 on each one of these edges. If it was 8 subdivisions, that means it's going to be 9 edges that it snaps onto. Not complicated to do. For the most part, that's it. And make sure it's static, because on top of everything, you don't want dynamic systems going on here. So we're going to go create hairs. All right, so the first thing you need to do is, okay, so we have to clean up everything. So we're going to open up, I'm going to just shift click this so I can see everything. What they normally do in the videos is they get rid of all this stuff that we don't want to use that's part of the hair system. So we don't need these, although we're going to be using these something similar to this to be able to make this work. Now, most often you're going to get somebody say, well, at this point, if we edit the vertices, we can see how nice this is already working out because it's following the curvature real nice. And if we rotate these, it'll always follow the normal on the surface. Well, in this case, that wouldn't make a lot of sense here. These are vertices, they don't rotate like that. So if I grab like this, I do this, you're getting that kind of thing, and it should follow the surface. Although it's not really doing a great job on one of those edges. But anyways, it doesn't matter. Most people will swear by this, and then they'll say, okay, well, now we need to make it so that it works with joints. So then you usually just do something like so. Well, maybe we might want to rename these real quick. So we go follicle, and it names it like that. So normally you'll have something like this, and then they go and create. We're going to create a joint, and we're going to make this joint. Most people that are locked into the Maya out of the box thing. They don't have a lot to work with, so all they can do is change the radius of it. So in this case, we're going to put it to 0.25. And it doesn't need to be anywhere in particular, because we're going to parent a whole bunch of copies. So we're going to go Control D until we get the same number of follicles as we do joints. And then what we do is we middle click and drag to just make them children of each one of these follicles. Kind of like what we had before, except now instead of transforms, we have joints following each follicle, and we'll fix their position in just a second. We're going to use our knowledge of coordinates. Always make sure it doesn't get in between. There we go. Oh, this one didn't. There we go. I'm just middle click dragging. It's not easy with a Wacom tablet. And if you know me, you'll know that this is always a thing that I have to deal with because of carpal tunnel. And even though I'm in Linux and there's a few things that don't work exactly right, the Wacom is saving my wrist quite well. So I'm going to set, since these are all, if they're all parented to the objects, if we remember our rules, our coordinate relative to, our coordinate will always be relative to our parent. So if we set all these to 0, they will go to their parent's position exactly. There's no offset from the parent. All right, so we've got all these joints now. Now what we want to do, well, at this point, that they also do is I've seen this done before too, like they show like, oh, it's locked on, look at how nice that is. Okay, so it's working as expected. And now what we're going to do is I'm going to make a duplicate of this, and I'm going to Shift P so it doesn't have a parent. I'm going to rename this to control_01. I'm going to change its radius, because these are the things that we're going to skin according to the traditional method of doing this. So 0.5, like something like that. And then I'm just going to make 3 copies of it, or 2 copies of it. Number 2 is going to be, I'm going to shift select the one in the middle. I think it's this one here. And I'm just going to match it, because we have tools that can do this stuff for us. We don't need to use snaps when we have tools. And then I'm going to match that there. So now we have those set up. This is usually we're getting really close to the end of of the base rig that is traditional in a Maya ribbon. So now what we're going to do is we're going to select these 3 controls, and then we're going to shift select the actual NURB ribbon. Remember, that's a NURB. And then we're going to go skin, bind skin. Now most often what they do is they go reset, and then they just set it to selected joints, meaning don't use hierarchies, just use these 3 free floating objects that are not part of a hierarchy as the joints that are going to be bound to the skin of this NURB. And for the most part, everybody does the same thing. They just go apply and close, and then they sit there and go, look how cool this is, look how smooth and curvy that is, that's awesome. And that's it, they're done. And if you've watched any of my other videos, you know that there's already probably 2 mistakes we've made. And you won't see it with default Maya. What you'd have to do in order to see the problem that you've created by using this method, you'd have to create, I guess, boxes or like rectangle shapes, and then attach that shape at least to the joint. Don't just parent it, at least just do a shape transfer to the joint, and then you could see what's actually going on. But since we are fancy, I'm going to just grab all of these and I'm going to show you why this is broken real quick. So the first thing I'm going to do is I'm going to add a bacon shape. For those of you that aren't too familiar with this stuff, with the Rigonomicon you get all kinds of tools, and it's added that shape to all of these. So you'll be able to add all kinds of just shapes to objects. You don't have to do freezing. You don't have to do any of that. It's all parametric. There is like a whole bunch of different shapes you can pick from. This is like a fundamentally necessary thing that you should have. So what I'm going to do here is I'm going to change the shape so that, let's see, it's going to be about 0.2, I think, roughly should be the width, like if I'm looking at it from this way. It's starting from there, so we need to make sure that, because box starts at the pivot, because if you have a joint, you want it to start at the pivot. That's the purpose of this, but in this case, we want it with a little tiny offset of maybe 0.1 because it's 0.2 as a size, so now it's in the middle. Then maybe something like, let's see, I think this one's going to be 0.4. No, this is going to be really tiny. This is going to be, because that's the thickness. And then the size Y is the one you want, 0.4. Okay, so now, and we're going to get rid of the X-ray ability. So these are all things that are really, really super handy. So if you're watching this and you're a traditional Maya, like you're trying to use Maya out of the box, I remind you that many of the big studios have their own in-house tools, and this is kind of something that's fundamental. You need to have some sort of way of displaying objects that don't add more objects. You'll notice that all we did was take the joints and give them a shape, but that doesn't add more sub-objects. This is very clean. All right, so anyways, now that we've created this, we have all these joints. Now we're going to start being able to see the actual problem. So one of the things that you should do is spin the one of the ends so you get to 180. 180 is the worst thing you could do, right? So if you're spinning 180 and you look at this and you go, that looks fine, then I question your sanity. Okay, seriously. Like, look, here's the first problem. If it's just a 180, then there should be a progressive change to spin to this value here. This one is almost aligned the same way as this one. That's awful. So we've done things in reverse in a way by doing it this way. So this is why you don't want to use this method blindly. If you do, you're going to start having issues like this. These are bad results. This is not good. So even if we're doing 180 and that's kind of like the limit of what you should be able to do with these types of ribbons. And I'm going to show you some methods to not be limited by 180 degrees. We'll talk about that later because we're going to be improving this. So this is our starting point. Our starting point is quite horrid because we're dealing with hair follicles that are being attached to NURBS surfaces that are being linearly skinned to be able to control them. We're taking the best thing. We've got the worst possible combination of things combined for a very awful result. So the first thing that you can do in order to fix this, and this is one of those few times where this makes total sense. So if you go to the mesh and you go to the skin cluster, don't use classic linear. If you've seen my videos before, you know how classic linear is done and how you can get this is literally the candy wrapper effect. So at the very least, because of how linear skinning works and how the values, how the transforms of the vertices are being blended, it will not create nice curvatures. So this is not what it should look like. So if you just switch that to dual quaternion, I mean, it's okay to use dual quaternion in this case. You're going to get a much better result already. This is starting to look like you're getting more of a nice kind of 180 degree rotation with you should be starting at this point and working your way gradually to the other point. That should be at the very least something you should aim for. Okay, so by doing this, it's pretty bad, but you're still at least getting slightly better. We're starting to improve it. Now the other problem is default skinning is going to be smooth, and you don't want smooth in skinning in this case. You want linear. You'd want to have linear values with a dual quaternion, not linear skinning with smooth values. We have it backwards. So we're doing it anyways. So what you need to do here is change the skin values so that at least we're going to get a linear response, so that this because right now what we have is a smooth effect happening for the end result. So if this at least was linear, it would be a little better. So you can do that through skinning, but it's going to be hard to do. What I would actually recommend for doing something like this, I would do. Let me just. Actually, I can leave it. I can leave it in this format. It's still fine. I can figure this out. So if we go to Window, General Editors, we're going to go to the Component Editor. Now, a lot of people don't know this exists even. We're going to go Smooth Skins. And I'm going to isolate. Let's see, isolate. There we go. So that we don't end up selecting things we shouldn't. I'm going to press F9, and then I'm going to go to these vertices, and I'm going to set these so that they're 100% following the control. This is one of the better ways to. I set it to 1, so it's 100% following that one. And I should do it for everything here, but I'm just going to do one strip, and you're going to see how this works. So in this case, we need to first remove any effect from the first controller, so that should be all 0. And the reason why we do that is so that it will normalize based on the values I give it here. So controller 3, which is the one on the on this end, should be 75%, if, you know, and then it'll automatically realize that it's only going to have 25% of that one. This sliver here, this loop here, is going to be the opposite kind of thing, where we're still going to get rid of controller 1 from the equation, but we're going to have 75% of that controller. And if we go to the middle one here, this should be 0, and it'll automatically do 50-50. So by doing something like this, and you do it for both sides, you're already going to get a much nicer looking ribbon effect, which means that the joints are going to be a lot closer to what should be a nice transition from the beginning to the end. Okay, so if you insist on using this bizarre method with follicles and such, and if you're really stuck and you can't, for whatever reason, my plugins aren't available to you in whatever company you're working at or place you are, even though I've done a lot of work to get it so that it works on everything, you can at least use this method with dual skinning, like a dual quaternion skinning and linear values, and you should be able to improve at least the quality of what you're doing here. You can write scripts that can help you build this faster and better, but generally speaking, I find that this kind of setup is very limited. So you're also going to find that I'm just trying to rotate it beyond 180 and it will pop. So you have to keep, oh wait, the other way. So you got to keep that in mind when you're doing this. So if I go the other way, it's also 180 in the other direction. So you have a 180 degree limit per segment, or between each one of these controllers, right? Because of the way, well, in this case, it's just you're not calculating this as a quaternion. You're not going to get very far with this method, unfortunately, and you're not taking the necessarily the value that's here and using that to transform the end result. That'll make sense in just a moment. Okay, so hopefully I didn't scare you too much with this one, and it's like if you've been using this method for a long time and it was in like linear skinning with like smooth values, I hope I've convinced you that just doing this alone will improve your results. But what we need to do now, and this is why I was saying this is a quintessential Rigonomicon video, is because this is exactly what I've been trying to do with the Rigonomicon. It's not just to make buttons that do things for you and that you get used to using it. We're trying to get behind what are we actually doing. That, by the way, if you can hear that, that's my sink. It's I'm looking forward to moving out of this place. But anyways, so hopefully it's not picking it up too much. The point of the Rigonomicon is to take a step back and go, why are we doing this? Why are we using nHair? Can we not do this some other way? And the answer, you can get started with this approach. So this person his name is Cole O'Brien. I think he works on Apex Legends actually at Respawn. So he's a technical artist that when he discovered that there was something called the offset parent matrix, he was very happy because now he could use the node editor to create a matrix and then feed that into a node in Maya. So this approach, and the thing that's really interesting is I would split this into two sections. The first section is this person is looking at doing transformation matrix operations through the node graph editor, and they're happy about that because they can finally use it and actually plug it into something. So they're happy to look at being able to use the transform matrix directly. Now, unfortunately, one of Maya's weaknesses is the fact that it gets as an input a positional value, a rotational value is XYZ, so we know it's like it's an Euler value, and then there's the scale value, and you can't really do anything about that. That's kind of core to Maya. In other softwares, you're able to just say the rotation. Let's forget Euler values. Give me a quaternion, and that scares some people. But you can also just in some programs you can even go as far as saying, forget all of that. Give me a straight up transform matrix that I plug in, and that controls the object, and you can put that into its own sub layers within an object, which is quite nice. And Maya is not very friendly to that kind of thinking because there's no way of actually connecting it. So that part is where I can come in and say I can help you with that. And there's a couple of things in the plugins that will allow you to set something up that works like this, but while still maintaining the position, rotation, and scale inputs that objects are expected to have. I wouldn't use the parent offset matrix. So if you're not familiar with what that is, if you select any object and you go into the attributes, any object that has a transform, so joints and transform nodes, which are used for meshes and splines and whatever, you'll always have a node. So if ever you're wondering about that, all you need to do is go into here, display shapes, and then it will split the transform from the actual shape, which was the hair follicle. In my case, the joint that we created and the shape that we added on top of it, right? So that's basically how we can see that. And anyways, anything with a transform, so that's only two kinds of objects. It's either a joint or a transform. And you should see that you have an offset parent matrix there that's now been included, which means you can feed it a straight-on matrix transform. Now, if you're not, that's what, I was saying, it's a shame that Maya's built the way it is because it makes this kind of alien and weird. So if I would actually almost say if you want to learn how to use transform matrices, you can do what I did, which is I learned it in another software, which was much easier to just plug in any value I wanted, and I got to learn how transform matrices work because I had direct access to it all the time, and I could write scripts that were very efficient and would evaluate very quickly. And I was able to basically recreate every constraint in any software like Maya and so on. And because of that knowledge, I was able to write plugins that use the Maya API or the dev kit to be able to do the math in C++ or with the Maya API 2 Python plugin method to write things the way I used. But you need to understand how this stuff works before you can actually start writing those things. So I would train in another software. If you're interested in that, let me know in the comments. I can maybe do I can make a way so that we can experiment with matrices, and I can show you how to create a transform matrix and on why it's so special and so fundamental to every 3D software that's out there. It's just that in the case of Maya, we don't have access to it very easily. So he got excited because he saw the offset parent matrix there, and he could plug he could do the other thing that I was mentioning is the second part of what he's doing is he's really looking into, this is the more exciting stuff. The part that I was interested in was how he's approaching how to calculate these things and to create these values that allow you to basically use Bezier or spline calculations to determine the transformation of an object. And if you're connecting the dots, we just did the ribbon, and the ribbon was awful because we can't, we don't have a means to do the math and plug it in. This guy is already figuring out the math, but he's having trouble connecting it to the objects. So so I'm going to go File New here. And we got rid of our grid. So I'm going to go into the constraints here, right click. You're going to find that there's a new section called B-spline ribbons. It's got 3 little dots, which means there's a menu. And I'm just going to create something that is basically based on what Cole O'Brien did. I figured one of my students found this and she was very interested. So I decided to take what he's done there and put it in here so that it generates something similar. So I'm just going to erase this. I'm going to select one of these and I'm going to show you what's connected to it. Okay, so they're all very small, but let me see if I can do something about this. So if I open this up, so everything that's over here, like maybe I can just do this, I'm going to press 3 on the keyboard, and then maybe see if I can, make it reconnect. Okay, so if you look at what he's been doing here, I'm actually using his scripts to generate these. I did these so that we can, try to do the exact same thing. And the only thing I'm doing differently really is at the very end, instead of connecting it to the parent offset matrix, which is a bad idea, and I'll explain why. The values that are actually controlling the object is going to be very Maya compatible. You don't want to use the parent offset matrix for a number of reasons. One, I use it only for initial values, meaning your like bind pose, because by doing that you zero out all of your values, and that's very helpful to us. But I never do it on a skeleton, meaning something that, in Unreal terms, I'm not doing it on things that are going to have skin and be exported. Why? Because the parent offset matrix was unfortunately botched with the FBX exporter. If you export an FBX, an offset parent matrix will be seen as nothing. It won't be exported, and it'll just mess up at the other end. So you generally want to avoid, and also you can trigger the age-old problem of scaling and reparenting, where Maya starts to create these subnodes to compensate for it. It's very simple. If you don't know what I'm referring to, it's like if I I'm just create an object here real quick, and I move it like so. This is another one. I just made a duplicate, and I make it a child of this one, and I just rotate this like so. And then I decide I'm going to scale you like so and like that. And now let's say I unparent it. You're going to see that you'll never ever get it back to not having a transform node in front of it. You can parent it to anything you want, and these new transforms will show up every time. Let's say I want to parent it to that. Now what you're going to find is that this object has a new transform, and now we have this. We have an orphan transform just floating around as well. So this is bad, and the reason why this happens is because instead of having something that can deal with that internally inside the object, it's more optimal to just add another node that is similar to what your parent used to have for scaling. For me, this is dirty, and as a result, you end up with basically never touching the method. You never touch scaling because of these kind of issues, and generally that doesn't export well either. So point is, here's his math, and what I'm doing is I'm doing things like just like any constraint where the values are actually being output to the translate and rotate. It's being converted, and the way I do that is with this little transform node called the output transform. Oh wait, hang on a second. That's not it. There we go. Bacon transform decompose. So bacon transform decompose says, I want to, you receive an input for a matrix like a world in world space, and then you give it some information. You tell it what it's. Even you can have an offset matrix if you want to. This I use actually for the preheat. Anyways, I won't go into too much detail here, but basically this node is a multi-useful node. Most constraints have this built in, and what it does is it converts that value of a world matrix into a local value that can offset also based on the join orient. So in the case of joints, we have join orients. You have to take that into consideration too. So it needs those values to create this basic value so that it'll output the necessary values to match whatever this matrix in world was calculated, and it'll calculate what the local values need to be for translate and rotate so that it ends up in the exact same place. So this is how I would approach this problem, because the other problem that the other method has by just punching it directly into the parent inverse matrix, into the offset parent matrix, by doing that you're also going to have other issues with parenting. So if you parent this to another object, well, that's being put on top of the offset parent matrix, right? So that's bad. You're gonna be fighting the parent connection. So with this method, you will be able to do any hierarchy that you want. You won't have to. You're not forced to have just these objects floating in space with no hierarchy. You're not limited to that. And and on top of that, you are now you can do things like every other constraint in Maya, where you can add keys and blend things and all that. So you're very Maya compliant, and you are functioning exactly like every other constraint in Maya. So hopefully you've seen this and you can see how this could be useful. Now this one has the same problem with the 180. So at some point you get kind of weird things once you start going too far. That's kind of normal. So this has its own peculiar issues. But for the most part, this is quite nice. And using the Cole-O'Brien method to do these blends with the transforms is actually really, really great. And you could do basically everything he's doing in that on that webpage. I'll make sure that I have a link up so you can go there and take a look at it. What he's doing is really, really interesting. And hopefully, if he ever sees this video or discovers this method, he'll be able to convert it so that he can just do any constraint he wants in the he can play around with transform matrices all he wants and then convert it so that it's usable in a production. Okay, so now I'm going to start. Now I'm going to talk about the one. I'm going to do a new scene. The one that I added that isn't this one from Cole-O'Brien. It's going to be bacon ribbon. So this is the official one that I've made. I'm going to just make it so that it's a certain size. You can change those values very easily, and I just have a default of 10 in between. And we're going to use twist values. You'll understand that in a second. We can try both, and I'll explain both. So I guess the first thing is, if you're somebody that's in a rush, that was how many buttons? You open one thing, you click a button, you're done. It's ready to go. So your ribbon is done. You don't need to do hair follicles and all that stuff and skinning, and it's direct. So if you look carefully here, it's created, making sure, no shapes. These are just the actual objects. This is it. There's nothing here. There's just the bones that you're going to use to skin and two controls. I have only two for a ribbon. I figure that's pretty good to make a ribbon. If not, you could just make more ribbons and attach them together. It's not really all that complicated. So we should have something that's very similar to what we had before, right? And I made this one. You have the option of separating this to separate objects. If not, you can just scale this. And I know we just talked about scaling. So if you don't like this kind of thing, you can. I'll show you the alternative. It's all there. So if you don't want to do scaling, it's fine. But I find this is a really easy way of setting up, for example, for facial rig. As long as the controllers are always leaf nodes and never a child node, it's going to be fine. You won't have the problem that we just discussed just a moment ago. So here's the thing. This is the root node, and then you have all the in-betweens, and you're going to notice that I also have visual stuff here that is helping you understand what's going on with the curve, so you're not just using the NURB mesh. And here there's actually a line for the basically the spline or the Bezier control that you're seeing. And then if I rotate this, here's where we're okay. So now we're getting a nice spread. It's coherent. It's doing what we're expecting. And the fun part here is you can keep spinning. And this works even if you reparent the stuff, as long as you're careful to make sure that this object, its value, its rotation value, x, right? So it's that's the thing that's controlling how it spins. And that all of these objects also started at 0. So if you reparent it, make sure that it's relatively 0. You can do that through even the joint orient. You just reset the joint orient, and you'll be good to go. And this should be pretty much everything you need. And it goes as many times as you want. You can keep rotating it. It's not a problem. No problem there. Okay, so now I'm going to show you the lerp method. All right, so I'm just going to move this out of the way. I'm just going to put that there, and I'm just going to create a lerp. So in this case, it's going to be 180, but if ever you have any problems using the value, like animating the value there, let's say you want to, because it's dependent on this thing's x rotation. This value is directly being plugged in to calculate the value. That's how I'm able to go over 180. I'm not using the world orientation, because if you're using a world orientation, then, you know, when you're doing your quaternion, it's going to find the closest one. So once you've passed 180, it's better to go 179 the other way. You know what I mean? So that is a fundamental understanding of quaternion rotation. So this is using more quaternion, but it'll be limited to 180, which in most cases will be more than enough. And you have absolutely no fear here at this point to parent this any way you like. You could have really crazy values. It's still going to work. It's always going to convert it into world quaternions and then do the math there. So I'm using methods that are similar to the roll bone. If you're not familiar with that, I have solutions that will solve the wrist spinning issues that you get from traditional methods that are, again, hacks or just workarounds with constraints that were never designed to be used that way. That's kind of that should be the maybe the slogan for Rigonomicon. Let's get rid of some of these workarounds and let's just go start building things that specifically target normal things that happen all the time. So that we need all the time. So in this case, if you pass the 180, it will pop, boop. But this might be the solution you want to use. So another possibility is, let's say I'm going to use twist values again so I can show you. And we're going to this time separate the tangents. So by doing this, we're going to have something that if you're an animator, you're going to be more familiar with this kind of control. Imagine this is a key, and this is the tangent on that key. And this is the tangent on the key where you're transitioning from to one or the other. And in this case, you have, like, you can do some things like that, and then the rotation again of the x will determine how it achieves that roll from one to the other, and this will allow you to do some pretty funky stuff. You have full control. Once again, just having to bear in mind that you have to use that value, and it's going to be passing that value in its calculation. Basically, if you're interested in what's happening under the hood, it's very straightforward. it's basically doing a Bezier 3 or a basic cubic calculation to find the position. It's going to use the derivative for that, so it's going to find the tangency along it, and that will determine an initial. So if I go over here and I go 0, it's going to place it so that it follows the point exactly with the one direction being calculated based on the tangency, and then it adds, it takes the roll, finds out how much of a blend there is from one to the other. So if I do that, it'll blend the value of the roll from one to the other and have it transformed by the calculation that we did before of where it is on that curvature. And all of this, even the graphics for this, is a shape. So it's a shape that's been added. I think if I select the shape, yeah, it's been added to the root node. So the root node is what makes those lines show up, and then the other little objects are there to drive the value for calculating how to draw these splines. So I think this one, I think I can rest my case now. I hope you agree with me that using a method like this, we're shortcutting a lot of the, I guess, BS that's out there, or methods that are just, look, you did what you could with what you had, but can we please start thinking about maybe writing tools that just kind of solve the problem directly? Because if you think about it, like if you look at any one of these nodes, it's really, there's nothing much to it. See, these are the things that control, like in this case we have tangent nodes, like the extra ones we added because we separated them. So if I grab this and I press 3 and then spread it up like this. So these, if maybe I can do this, let's see here, something like this. Okay, that's this guy here, and we were just selecting this object, and this is being calculated because we have that's the root node. It has to be there, and because it needs to know relative to what. It does all this relative to something, and it compensates for the hierarchy. And it has all these nodes that are being used for values into what I call the bacon ribbon. This is the bacon ribbon. It's a constraint, just like any other Maya constraint. And I think, let me see. Yeah, so I usually have it more organized, but this is a fresh install in 2026. But so we'll get the default order, which is, well, this is it. It's a little messy, but it's still readable. You have, if you select it, you'll see all the stuff that I've thrown in there as options. You can make it calculate based on segment counts. You can make it or based on a path percentage. So let's say this is this object here. Oh, wait, I must have turned off the there we go. Okay. I must have pressed the wrong button. Okay, so if I go back to this, if I want to, instead of being a segment count, we can go by percentage if you want to use and do this manually. And you can just tell it where on the path the percentage is. And you can pre-calculate that instead of using the segment count, but I find this is much cleaner and much easier to edit later, and it's not much of a thing to calculate. Then it's telling it how it rolls, either it's through lerp or through that twist value, the value, the x rotation. You have to figure out something has to be an up vector. For think of like ik on arms and legs. You have a pole vector that basically tells you where up is. For these things to then calculate, there has, that's where the 180-degree line basically exists based on that, choice. And then you have the vector direction. It's okay. So for the most part, there's not much to it. There's an object and which axis you want to use is basically what that is there. Okay, I didn't want to gloss over it too quickly, but there's not much to it. If you want to use these constraints yourself and do your own fancy stuff, that's what it's for. Like I'm using this for the bendy bones. So bendy bones is the same constraint. It's just that it's set up differently. That's all. So if you know, like, I don't know if I could load up the bendy bones. Oh, maybe. Let's see here. File, open scene. Might as well be thorough. I'm going to go to. Let's see here. It's under projects. Dawson. I think we had it in. Yeah, Malcolm Arm Bendy roll. I think with that we should be okay. Don't save. Yeah, so if you look at the... Oh, this is for the roll. Oh, okay. So, well, the roll... Well, I was talking about this before, so I might as well just show you real quick. What you do is you select the point of reference and up to 4 objects, and then you just go under constraints and you just go roll bones. And now, as this animates, you'll see that it's only going to spin if you spin the hand. And then it's going to pass a percentage of that. And this is very safe in the sense that you can go pretty far and it works just about every angle. So also, you're limited by 180 degrees in one direction or another. I mean, for a roll bone, if you're more than 180 degrees, it means your character is not really, is going to be maybe you can change it can be changed, like it can be changed so that it does do that, but anyways, so I'll see if I can find really quick 11 bendy bone. There it is. Okay. And this is an old one, so it had old bacon shapes. We're going to fix those right away. Now, if I recall, I had a... So basically what all this weird stuff looks like, these are the dark blue stuff, like this one. It's supposed to be the arm, so like the joints. And then these are the objects that we're going to use in order to create a bendy bone. So I'm just going to grab this guy and move him over here and just go like so. You're going to see why this is so close to what we were doing before, and it's the same constraint being used differently. I upgraded it so that we can do all the stuff that we did previously. So all you need to do is select the starting point, the first tangent, the tangent for the other end, the last point at the other end, and then in order of the bones that you want to lock on as a bendy bone, and then you go constraint, bendy bones. It should lock right on. And now if you move this like we were doing before, it has this kind of feature where what you would do is these would be your joints for your arms, and these smaller ones here would be the ones you skin to. So the arm would still work if you skin to these just the way it used to, but now you have the add bonus of being able to do this kind of stuff where you can do some fun stuff and stretch out the arm. And if you combine it with the roll bones on the other ends, you can get some really nice deformations for arms and such. But the stuff that I've been showing you with the Maya or the bacon ribbon, it will allow you to, and I've been experimenting with this ever since I put it together, and I might make a video very, very soon, hopefully not as long as the last time, and we can talk about how to set up a facial rig with ribbons with this. It's quite nice. You can do some amazing things, and you're not creating a million nodes in Maya. Everything is optimized and concentric to these little tiny constraints or calculations, and you're taking advantage of the multi-threading updates that are happening from Maya. So it's actually quite nice. So hopefully you also enjoyed the fact that we were in Linux and it was pretty smooth. In fact, if anything, I'm amazed on how much of performance I can get out of the Linux Maya version. I would easily say that it is the best one out of the three, because you just have so much of your resources available and everything just flies. You're never being there's no Windows update that's slowing things down in the background. None of that malarkey. So it's really good for working in peace. And I strongly, now that I know how to set up Maya inside of Linux, it's actually becoming my favorite of the three. And that's scary. I never thought I'd say that. But yeah, the Mac one is now the worst one out of the three, simply because Mac hardware is pretty awful if you're a 3D artist, because you're going to be paying through the nose to be able to get even some RAM. And since they're gluing all that stuff in there with that epoxy, claiming that it's for water resistance, it makes it almost impossible to upgrade. So you're stuck with whatever you bought originally, and it's difficult to, and it's very expensive to even go beyond 16. It's like, there's a few of them that have good options for 64 and such, but it's just sad how expensive it is on Mac. And as a result, you're always swapping, and you just open up like 2 Chrome tabs, you're done. And there's nothing left for Maya. And also the fact that it's a shared memory, meaning what used to be video memory and the main memory is being shared. So you're not even getting the memory from the video card, because there is no video card. Everything is on that new fancy Apple Silicon, which is overall pretty good. It's pretty amazing for certain things, but not for this. Really not for what we're doing. Okay, so enough about I don't want to fan the flames of the wars between softwares and OSs, but please enjoy that it works on whatever it is that you want it to work on, and let me know in the comments how it's going for you, and if you started using these constraints. Also, just a quick reminder for anybody who's not familiar with these tools. It's MIT license, it's open source. I compile them as quickly as I can for each version of Maya, and once the full version is out, it's just a simple, it should be as easy as just downloading the latest dev kit and compiling. I have a really good setup now, so you will always have these plugins available for free at any company that you want. And you shouldn't be blocked by this, so don't feel afraid that you won't have access to this. Also, it's open source, so I'm leaving the source open. If you know people who can do that kind of thing, they can compile it for you. That's what tech artists are there. In any company that you're working at, there should be a tech artist that knows how to compile plugins. So there shouldn't be any issues with that. All right, so hopefully you found this video interesting. And I hope I wasn't too detrimental on the methods that are being used usually with Maya. It's very frustrating for me, because I keep bumping into, like, just recently I was talking to a AAA studio, and they were using it's a very, very well-known studio, and they were using the Maya ribbon, and I was like, okay. And so it just goes to show that this kind of stuff is everywhere, and hopefully you will be working with people that can see beyond what is considered standard, and we can finally get past that. All right, have yourselves a great day and enjoy the tools. Let me know if there's anything that breaks.